going to be giving a walkthrough on building a Standup bot plugin on the Cisco Spark platform from the perspective of a HipChat webhook plugin developer. Now, the reason we're going to build a Standup plugin is that's something that has widely desired from some of our teams in the HipChat server product, which we've had to deliver them, that they were using in the HipChat cloud product. And it's something that we want to make sure that we can give to our users for the pilot that we're about to run for the Cisco Spark platform. So to get started, I'll just give you a bit of a demonstration on what the functionality is that we're looking to implement. So what we're going to do is create a new room, and we're going to add Tobias to this room. I'm also going to add the Standup bot to this room. Great. And now what we're going to do is say, welcome to our, and that's now created the room. And we'll just give it a good name. So that's all done. Now what I'm doing, I'm going to jump on another device from my other user, and we'll put a Standup entry in. And I'll create a Standup entry from this user as well. Now if someone comes along to the room, they want to get a report on what the situation of the Standup is, they can just go /Standup. And the Standup bot has now replied, cool, Tobias is working hard, test user is making a YouTube video. So it's really simple, but hopefully it's going to be enough to give you a good insight on what's involved in building a bot for the Cisco Spark platform. So I'm going to break this up into a few parts. And the first thing we're going to do is we're going to have a look at the communication flow. So there's two communication flows involved in the plugin that we're building today. The first one is when the user creates a status message, just like we just did. So that's creating a message, which then goes to Cisco Spark platform. The Cisco Spark platform is going to instantiate a webhook notification, which then goes to our Standup bot. The Standup bot then goes back to the Cisco Spark platform to get the decrypted message contents, some information about the person, so that we can then persist that, so then when the user wants a report, we can deliver that back to them. The second thing that Standup bot does is every 60 seconds, he gets a list of all the rooms that the Standup bot belongs to, and make sure that a webhook has been registered for those rooms. Now this is a little bit of a clunky approach, but just with where the API is at the moment for the Cisco Spark platform, it's the only way I could get this to be automated. So just to give you a little bit more detail on that flow before we jump into too much code. When the webhook notification arrives, so that's just a message that's been added to a room that the Standup bot has been subscribed to, we retrieve the message content and the person details from the Spark API, determine if the message requires a new Standup status entry or a Standup report to be generated. If it's just a status entry, we persist that to our database. And if it's a report, we generate the text for that report, and then we post the report content back to the room using the Spark API. As far as registering the room, so it can receive, so the Standup bot can receive webhook notifications that messages have been posted there, we've got a cron job that's initiating the refresh. I'm using the Spring Scheduler in this particular application, but I've implemented it so it can also be done from an HTTP endpoint. And that's really useful if you're using a stack that doesn't support its own threads being created. For example, the Google App Engine. Or if you just want to manually force an update to happen as well, if you don't want to wait the full 60 seconds, which is handy during development. So we do that cron, something's instantiated it, said, hey, I need to do an update. We retrieve a list of rooms back from the Spark API for the Standup bot user. We retrieve the webhooks registered for the Standup bot user, and we identify the rooms without a Standup bot webhook that the Standup bot is a member of, and then we register a webhook for these rooms. The application has been architected using a pretty standard Spring Java approach. So if you've got some experience with Spring and Java, this is going to look really familiar to you. If not, hopefully this is reasonably straightforward. So we've got the Spark API or a cron job that's interacting with our controller. And then that controller has two endpoints, one for the webhook notifications, another one for that webhook registration, that cron job entry point. We then go to a business delegate, and that business delegate is just providing us a nice abstraction of the Spark webhook API definitions from our domain level objects from our business logic. That just means that if in the future the Spark webhook API changes, we only need to change the controller and possibly a little bit of the business delegate, and our service and our data access layer can be continued to be used without any further changes. The service layer performs the business logic of orchestrating the functionality of the bot. Again, this is really straightforward, but I just wanted to make sure that we had a good solid architecture in place. And then down to our data access layer. So we've got abstracted access to both our persistence database and our API. So using Spring Data, and that allows us to really easily switch out the database interaction technology that we're using. So in this case, it's just JPA. It's going to an in-memory database, but we could plug this into a MySQL database, or you could write your own database implementation if you wanted to. And then I've also just built a wrapper, a very lightweight wrapper around the Spark API that the service can use. Just so if there are changes in that Spark API in the future, we don't need to go and modify how that service has been implemented. Alrighty, so we'll have a little bit of a look at the code as well. So our controller, really straightforward. We've got a request mapping here for Cisco-Spark-Standup. And it's simply just passing that request object down to the business delegate. The refresh endpoint, just calling the business delegate and saying, hey, can you update me? We've also got a Spring scheduler method here, which is calling the business delegate and saying, cool, let's update the webhook subscriptions that are available. In the business delegate, very simple again, we're just pulling these fields out from the data object on the request. Now, also just to note, the Cisco Spark webhook request, we've created a model of that. There's a tool, org.json schema to Pojo. If you Google it, you'll be able to find it. And you can just take the example JSON that's in the documentation on the Cisco Spark documentation website, and it will create some nice Java Pojos for you to utilize. So it takes the data object out of the request and then takes those fields out individually. So this just means that we've got this business delegate layer here. If it did change, and maybe this get ID changed to get message ID, we would be able to just change this part without having to change anything else within our code base. And when we're updating the Standup webhook subscriptions, we're just passing it straight through to the service. In our Cisco Spark service, we're performing our business logic. So we're injecting a reference to our API wrapper. And here we process the webhook. So the first thing we need to do is retrieve the message from the Spark API. So the Spark API only returns a key to that message. It doesn't actually include the message in the webhook. And they do this from a security model, which is really handy from a governance perspective. It's a little bit more work on the API side, but definitely worth it. So we go grab the message from the Spark API. Now we've got a message object. We get the text, and we make sure that it starts with /standup. So right now the Spark API is just going to send every message to our webhook. We can't subscribe just based on particular prefixes. So we just need to make sure that it's a message that we're interested in dealing with. So we're only interested in dealing with, if you've got /standup, we're going to record stuff. There might be some other chat going on in this room. And that's fine. We can leave that continuing as is. So we get that message text, and we're just going to remove that /standup from the message, so that we're only working with either the entry, or if there's nothing there, then that means that we want to get a Standup status report. So if it's a status report, what we're going to do is we're going to go to the Standup service. So this is just an abstracted service for interacting with Standup operations. The reason we've got that there is so that It's a single point of functionality that also the HipChat webhook is using. And then eventually, once we've deprecated HipChat and we've gone Cisco Spark enterprise wide, we can just deprecate that off to the side. But it also gives us that extensibility. If there's anything else in the future that needs to interact with this, maybe you've got a intranet page or something that you'd like to have this history coming from, or maybe post it into something like Jira, you've got a good isolated service there that provides that functionality. So we've gone to that service, get stand-up status for that room. It's just returning us a iterable of stand-up statuses. And then we just go through those stand-up statuses. It's a bit rudimentary here. We're putting a list together using new lines. And we're doing a string format. We've got the user display name and then the message afterwards. Hopefully in the future, the Spark platform will allow us to enrich those messages with maybe some HTML, some bold, something like that. And if that's the case, we'll just be able to update this piece of code here. And once we've built this up, we then post the message to the room. So this is going to the wrapper. We give it the room ID, and we're just taking that string, which is just a string of those messages. Otherwise, if we haven't requested a report, then it must be a new status being posted to the room. So if it's a new status being posted to the room, we're just creating a new stand-up status. We need to get the person first, so we know who they are. We get their display name, we can set the message, we can set the room ID, and we set the user ID. And then we get the stand-up service to save the stand-up status. So pretty straightforward. From updating the webhook subscriptions perspective, we just create a little cache for the duration of this method running. That is a synchronized method just so that we don't end up having a race condition of 2 rooms being identified requiring a webhook at the same time, and then double registration before it's been checked again. Now, obviously, this isn't going to scale out to multiple nodes, but again, this is just a simple example. So we go to the Spark API, we get the webhooks for the API user, and get the room IDs, and we pop the webhook and the room ID into that map. And then we go through every room and we make sure that we've got a webhook for those rooms. And if we don't, we go to our wrapper, we register the webhook. We're giving it a name of the Standup bot webhook. We need to give it a target URL. Now that needs to be publicly facing to the internet. That's really important. And that's just the URL that it's going to be calling back on. What we're looking for, messages and the event type of created, and the room ID that we'd like to be subscribing against. So at the moment, the Cisco Spark API only supports the created event. Hopefully in the future we'll be able to get a little bit more detailed on that. But for the purposes of what we want to do today, that's going to be enough. The stand-up service just goes to our data access object to find the room when we're looking for the rooms, for the statuses for a room, and if we want to save it. We populate the ID, which is a combination of the user ID and the room ID, and then we go and save that with our data access object. The data access object is using Spring Data, just need to define the interface, and Spring Data does the rest for us. The Cisco Spark API wrapper. I do actually need to make sure that this SDK from Cisco that I've grabbed off GitHub is thread safe. Sure it is. There just wasn't any mention of it on the GitHub repository. So we're injecting in a connection object called Spark. If you have a look in our configuration here, we inject in the Spark API key as an environment variable. Then we use the Spark builder to create that authenticated connection. And that's being auto-wired into our API wrapper. And the functionality that we've wrapped up, get message, got message ID, room ID, then calls using the Spark API to get that. Same for person, same for room, same for the room membership for the API user. When we want to post a message room, a little bit more involved, we're just building up that message object so that our service doesn't need to be aware of that when we're posting to the room. Get the webhook, very, very straightforward wrap, and then registering the webhook. It's a similar situation with needing to build up that request object. There's a little bit of formatting required, so room ID equals on the filter. But we've just built up that request object and dropping it into the API. And that, from a architecture perspective, is how it's put together. So we come in from our entry points, hit the business delegate with our abstraction, perform our business logic, then go to our data access layer, whether we're persisting for the Standup entries, or we're going to the Spark API for other functionality, like posting messages to a room, or updating the webhook registrations. Got full unit tests over this functionality, so you can review that if you're interested. And then there's an integration test as well, just to make sure that everything's functioning as intended. And you'll need to make sure that environment variables have been set, otherwise this won't function. But what the integration test is doing, it creates a new room for the test. Now it's destructive actually firstly, very important to clean that out. So you'll want to create a new user to test this with. Handy tip, by the way, is if you've got Gmail, you can just put a plus after your username on Gmail. So it might be my username plus test@gmail.com, and everything after the plus, Google ignores. It's just an easy way to create additional test accounts. So using your test account, it'll clean that Spark environment by deleting all the existing rooms and webhooks. Then, for the actual test, we'll create a new room for the test. We trigger the update of the webhook subscriptions. We check using the Spark API the webhook successfully created. Simulate a webhook request for adding a new Standup status, and we have to simulate that injection in there, just because generally our local machines won't be publicly accessible from the internet. We want to test the end-to-end functionality. We're going to check the room to ensure that the message has been correctly populated. We're going to simulate a webhook request for adding a new Standup status, and then we use the Spark API to make sure that those messages have been correctly posted. After we're done, we're going to clean the Cisco Spark environment by deleting all the existing rooms, just so it's nice and clean for the next test to come along. So you can check the project out and you can run that if you just want to see end-to-end how that is all put together. For the data setup, we're just using the Spark API directly without wrapping it up. But for the actual functionality, we're using mock MVC, so it goes directly through all of those layers. And putting all that together, we end up with this